We are Team 5. I'm Ryan. We also have Kevin, Rasif, Marcelo, and Brian, and we are here to talk to you again today about DDoS attacks. In the past, we've talked a bit about recent trends with DDoS attacks, and we've also talked about DNS servers and why they specifically are vulnerable to DDoS attacks. Today, we're going to talk to you about more general topics like classification, the motivation behind DDoS attacks, general effects of DDoS attacks to specific companies, and then we're going to get into detection, prevention, and mitigation techniques, both in general, and we're going to present some specific solutions and services that are out there on the market. So first, we're going to talk to you about classification methods of DDoS attacks. These kind of have to do, there's different ways to do it, and they kind of have to do with different aspects of the DDoS attack. And the first method of classification is by automation. And there are three main ways to classify DDoS attacks this way: manual, semi-automatic, and automatic. With manual attacks, it's pretty much all done manually, from scanning different systems to find vulnerable agents, to implementing the code and then initiating the attack. With semi-automatic attacks, automated scripts are often used to locate and exploit vulnerable machines, and then once that part is taken care of, the attacker can manually choose the type of attack that he wants to use and then initiate the attack. And then automatic is, it's pretty much fully automatically run. Go ahead. The next classification method is by scanning method. The first way is by hit list. This is pretty straightforward. There'll generally be a set of IP addresses. So the first computer will scan this whole list, and when it comes to a vulnerable machine, it'll exploit that machine, implement its code, and then cut its list of IP addresses to attack in half, give the first half to that machine, keep the second half, and then they'll both keep scanning that way. The third way is topological. With topological scanning, information is looked for on the machine to be infected. This is pretty common with email worms. You'll see the code be implemented, and then it'll scan the machine for an email list, and it'll move on to try to send its code to all the different machines on that email list. The last method is by subnet. This is pretty straightforward. Once the machine is infected, it then just goes on to scan the rest of its machines on the subnet to see if they are vulnerable, and then try to attack those as well. And then you can always use a different combination of these different kinds of things. Then communication is kind of the next classification method. And this has to do with how the attacker connects and talks to its different agents or zombies. You'll see different things. Sometimes you'll see these referred to as masters and zombies. Sometimes it's handlers and agents. With direct communication, you'll generally see with direct communication, you'll generally see the attacker use the master as kind of a middleman. With indirect communication, you'll usually see internet relay chat used instead. That's kind of a newer method that's been taken on. And then finally, the last classification method is exploited vulnerability. Talked about these a bit before. The first way is basically just a brute force attack, and the final way is just by protocol, TCP, UDP floods, those kind of things. Go ahead. And then motivation. I'm just going to touch on this real quick. There's generally two main methods of reasons that people do these. One is by financial motivation. The other is hacktivism. In the past few years, hacktivism has really surpassed financial reasoning as for why people are initiating these DDoS attacks.
so what we're going to talk about in the next two slides are actually real-world examples of the destruction, you can say, of what a DDoS attack can do. In December 2014, Sony was attacked around Christmas time. So you can think about that time when everybody's buying their new PlayStations and new games. They had a 3-day outage, pretty much. So anybody that tried to connect to, or anybody that purchased a PlayStation 4 that tried to connect to the servers on the other side couldn't get through. Even if you already had one and you just bought a standalone game that tried to connect to a server somewhere for, like let's say a MMO or something, a multi-player online game, no connection whatsoever. Sony PlayStation Network brings in about 1.2 billion annually, and the responsible party for this one was Lizard Squad. To the best of my knowledge, Lizard Squad are a bunch of script kiddies that were using tools, actually, DDoS tools, to bring down the network. Their motivation, they were testing their tools. They were advertising their tools. They were advertising their services. So they get future customers to use those services for malicious reasons, I'm sure. Losses for that 3-day outage, roughly, Sony lost $10 million. Compared to 1.2 billion, that kind of seems like a drop in a bucket. But if you think about it, I mean, $10 million is a lot, and you have a lot to answer for it. If you have like shareholders, like we lost a lot of money. Disclosure. It was pretty evident when the outage happened because no customer was able to get online. Sony did have a maintenance page where they kept putting status messages up there to see if their network was up or down. They also kept everybody in touch through their social media like Twitter, probably their Facebook page as well. So everybody was pretty much aware, their users were pretty much aware what was going on at the time. Go ahead and up the disclosure. The next one just happened recently in March. It happened to GitHub. GitHub.com is a social coding site. Git itself is code, and the website is a large repository for all those codes, all those projects that people can create worldwide, of course. The two projects were attacked that were Greatfire and CNNY Times. What makes these two special is that they're anti-censorship projects. Citizens in China actually use these two projects to circumvent the quote-unquote Great Firewall that the Chinese government has put up, since they're filtering and censoring a lot of stuff that's on the internet from their citizens. The method was somebody injected some bad code or malicious code into the Baidu search engine. Now, Baidu is a very popular search engine in China and in Asia. And when anybody visited that site from any location, it opened up connections to these projects. So it just flooded their connections and it brought them down. Now, the Chinese government is suspected of this only because at one time before, they had locked GitHub itself on their firewall to their citizens. And this seemed more like an insider job because it seemed that the code was very much embedded into the search engine. That it would take somebody from the inside to do it. Now the losses, even though those two projects were targeted, all of GitHub went down. So nobody was able to access any of their project, any of their code whatsoever throughout that time that it was down. Disclosure, the same way as Sony, they had a maintenance page up that let them know the status of the site. So everybody pretty much knew what was going on. In comparison to the Sony now, there was monetary loss. On Sony's side here, it was more of a loss of access for the system. So it seemed more like of a political kind of motivation on this side.
There are some approaches to DDoS protection. One is victim end approach. This is a little costly because there are many devices in the network, and when you we can consider other methods as well. One method is source and approach. In this approach, you just don't put the perimeter devices here, but they can also be here. But what you do is you try to protect the devices that attack is started, so that you can protect the network and also the target. And the intermediate network approach is very effective, but it needs collaboration of all network backbone. In this approach, wires, the internet infrastructure, in every node of that infrastructure should be protected against DDoS and should communicate with each other to better protect against DDoS. And this is not happening in the near future. And there are some attack detection methods. These are software-based methods. One is statistical, and this is about just using well-known statistical methods to overcome attacks. They are just trying to shape what normal traffic is and differentiate between normal and anomalies. And there are some different approaches like standard deviation of traffic, change patterns in traffic, resource usage anomalies, etc. For example, your customers are coming from specific IP addresses, and abruptly there has been new IP addresses, or the traffic was peak times was at a definite interval, and abruptly it changed, the traffic pattern changed, and that's how you understand that there's something different going on. And soft computing pattern method uses fuzzy logic neural network. Like these mean when you can't find the right solution, exact solution, you try to approach that solution. And these tools provide the way to approach the better way to solve problems. And this could be regarded as a second step from statistical methods. And there are knowledge-based methods. In these methods, we make use of statistical tools and also soft computing. But what we do here is we create a knowledge base, very complex rules, and actually we are trying to gather our knowledge about DDoS into software, but in an artificial intelligence way. That way we can approach the problems ideally, and these methods proved to be really good methods against DDoS. And finally, we have low-rate DDoS attacks. They are very low in number, but they are exhaustive, like using search features of websites. One search method, one use costs many resources in the server.
So as we go through, you see that the fundamentals of the attacks are basic principles. Part of that is to plan and understand what your environment's doing and prepare for the attacks. They're almost inevitable. So to plan for an attack, to have a plan written down, documented, and ready to use, to practice and rehearse that plan. This is simple ITIL functionality, and have a disaster recovery plan. Those are the major ways to get through a denial of service attack and to mitigate it. What are those? Next, please. So the concept is to understand that this is the simple way to get through it, and it's pretty much what the appliances are doing. Traffic violation, validation, and denial of service lockdown, DNS lockdown. Cisco best practices 38 basically says that there are two best methods. One is to follow the best practices. This is over 10 years old. They're still valid, but they're often not followed. Limiting access is probably the best way through DNS lockdown. Access control list is another way that limiting access to your network, which will help prevent and mitigate DDoS attacks. Managing network traffic, either by IP, MAC, or other ways, is the best way to keep people that you don't want your network out of it. Simple, challenging passwords except at the IP or MAC address level. In larger networks, this can get kind of complicated and become quite a challenge. So access control list compression can be used within technology, is often a component of major appliances. Rate limiting is also another way, basically constricting what happens. As you heard from some of the attack methods, limiting the rate, limiting the flow of traffic into and looking for anomalies, understanding what your environment's doing and working through that and monitoring it is the best way to understand when someone is attacking you. Establish a baseline, of course, revalidate it on a routine basis. But you've got to understand the topology and architecture of your network, and you've got to know who your customers are. Who is using the environment that you're on and responsible for? Next, please. Okay, combining ACL and rate limiting, the best of both worlds, basically. So by having an access control list, limiting the access, using the proper technology to support your customer base, and then applying rate limiting at the same time is currently the best method that's used. Again, many appliances do the same thing. These are the fundamental skills, but this is the way to best mitigate these services.
Thanks to Brian and Rasit for sort of covering what you can do as a business by yourself, essentially with hardware and within your network to protect from denial of service attack. I'm going to cover a little bit about what you could do with a service provider in a cloud environment to help also mitigate and take some of the risk off your own books. So this is known as the hybrid approach, and I'm going to cover a little bit of that, and then Newstar's April 2015 DDoS Attacks Prevention Report. They're a company based out in Sterling that is doing some really cool mitigation stuff with denial of service attacks, and then also some of the major players, Akamai, Encapsula, Cloudflare, yes, and Newstar. Next slide, please. So how Newstar defines the hybrid approach is an always on-premises hardware blocking attacks instantly plus cloud-based traffic scrubbing to handle larger strikes. So the biggest part of that is the hardware scrubbing part. So some of the numbers that they came up with were 43% of the industry as a whole invests on hardware plus cloud-based mitigation, aka the hybrid approach. 94% of the financial companies that they surveyed chose a hybrid approach when peak hour losses are over $100,000. Financial companies sort of lead the way in hybrid mitigation, as well as technology companies. So hopefully companies begin to follow their lead in this realm. Next slide, please. Again, so these are the tech companies that they surveyed. Just something that you might want to think about if you're a CISO or a business owner. 65% of the tech companies attacked are 6+ target times a year. Nearly half of all the tech companies attacked would lose $250,000 an hour if their sites went down during prime time. And half of the tech companies surveyed experienced a data breach. So again, going back to the hybrid approach, they are using it. If you find yourself in one of these categories, you might, or you definitely should be considering it yourself. Next slide, please. So the services that these companies, cloud companies, would provide for you are firewall-based IP prevention, website application firewalls, CDN providers, load balancing, DNS server protection, and real-time monitoring. So what this means in terms of the network, they give extensive network 3 and 4 as well as 7 protection. And the biggest thing that they can do for you is protecting your website or application against a massive DDoS attack without having to pay upfront for the bandwidth that you use on a regular basis or that you would need on a regular basis. So essentially what they provide for you is high-powered scrubbing hardware. And just to give you an example, Encapsula, one of the companies that we looked into, they found that DDoS mitigation kernel modules showed that Linux can only handle up to about 3 million packets per second per machine, which isn't cost effective at all. So what Encapsula offers is something called the Behemoth, which actually mitigated the largest attack by Encapsula to date, which was over 67 million packets per second. It's capable of scrubbing, and it did that in Los Angeles in a server. Behemoth has the capacity to handle over 1 terabyte by equipping its data centers with this high scrubbing power hardware. They also give you content delivery networks, which the core function of those is to provide application acceleration and load balancing. Next slide, please. So just to give you a summary of some of the costs that we researched for this, Akamai's bundle for enterprise web services is about $13,000 a month, and they also have overage charge insurance. Essentially, if you go over the bandwidth that they provide, the insurance that you have to pay for is $5,000 a month to cover any overages. So they could cut out your bandwidth in the middle of a DDoS attack if you don't have that insurance. There are new players though in the game that are sort of really undermining companies like Akamai. Encapsula and Cloudflare offer premium enterprise CDN with 24/7 support and enterprise-grade uptime SLAs between $4,000 and $5,000 per month with no charges, no overage charges. Next slide, please. So Arbor, Akamai, and VeriSign are some of the big names in this game, but Cloudflare, which started out just a few years ago, it has rock bottom prices that are attracting new customers that are rated $1,500 per day. Also, on any given day, 25% of the internet's visitors pass through its network, so it grew at an exponential rate. Neustar is also a DNS attack vendor. Akamai is known for caching and content delivery, but Cloudflare is excellent and faster at doing both. Next slide, please. And also just one more note on the emergence of these new players into the game and offering lower pricing. So Akamai and the big guys have been around for a long time, but what wasn't there before that is now is a decline in the cost of bandwidth, development for multi-core processors and the rise of programming for massively parallel processors, and also SSD drives that provide better input-output operations per second. So what this means is these companies have adopted these things and been able to implement them and turn them into products quicker than the big guys like Akamai and the other ones could do. So they're looking in pretty good shape. So bottom line here, this is the manpower required for a DDoS attack from the Neustar survey. 36 As DDoS attacks get cheaper to carry out, and also going to Team 4, ransom attacks on the rise, I think targets will begin to increase. So if you can afford the $45,000 per month for one of the cloud service providers to take care of a lot of this stuff for you, you'll probably be in pretty good shape. Enterprise companies, on the other hand, have absolutely no excuse not to have a hybrid approach to this. Thanks. Any questions?
So you guys talked about with ACL filtering and one of the defenses. How would you, does that approach change now that people are connecting, for example, from their clouds? So, they'll be getting different IP addresses. How would, I mean, if you're connecting, for example, from a Google will use different servers you would be connecting to. How does that complicate?
The access control lists are identified by one way or another based on what method you're connecting to. So you're using some source of identification. So once that section, the IP packet is identified as yours, then it's let through. It's when they come from different places, which often happens in the denial of service attack. This prevents the same source delivering itself from 15 different locations, and the cloud doesn't prevent that from happening.
The third-party mitigating companies that I talked about as well have proprietary algorithms that they use to identify some of these things that also change on a regular basis. So that's really good identifying service that they provide. Any other questions can be emailed to us. We appreciate your time. Unless anyone, I'm sorry, Leighton had a question.
When you were mentioning they were able to provide extra bandwidth, so can one speculate that if you're receiving a DDoS attack, their bandwidth allocation will, in essence, load balance to keep your network up?
Yes, correct. That's exactly what it means. And the example I gave, this thing called the behemoth can process up to a terabyte. So that's a terabyte in bandwidth. So that's a huge amount.
So that's what they're 5,000.
Yeah, and typically, like, the bandwidth DDoS attacks have been on the rise. I think the biggest one to date is like 400 gigabytes.